Hello everyone, my name is David Townsend. I'm a partner sales engineer here at Juniper Networks, and it is my absolute pleasure to take you through this second session, which has been hosted by a partner, Kubus. And this second session is focusing on day zero, i.e. building and designing data centers from our solution, which is Apstra, which uses intent-based networking. But before I continue, I'd like to say a big thank you to our partner Kubus for hosting these series of sessions. And if you do have any questions or queries, please contact uh, the team at email sales@kubus.com, and of course they'll be more than happy to respond to any questions and queries that you may have. So let's begin. So as you may recall from the first session on Apstra, maybe even the sessions which we hosted on Mist, this might be a familiar diagram by now, but under Juniper's portfolio for the enterprise, our true north is experience first networking. So whether it be the AI-driven enterprise, Mists and the switches, the Mist APs, the SD-WAN within that, or the automated WAN using our session smart routers, tunnelless technology, using secure vector routing, or the actual discussion topic for these sessions, our cloud-ready data center. Everything is about experience first networking. We put the experience first of the network itself, and actually those administrators and operators who are actually deploying, operating, and monitoring the network itself. And of course, all of this is connected, underpinned by our connected security. But when we talk about cloud-ready data center and Apstra, we are talking about creating an assured and reliable data center, which of course uses a zero trust model, automation, of course, and also intent-based networking, but it's about making it reliable, i.e. trustworthy. And what are actually the pillars of creating a reliable data center? Well, the four pillars are designing, building, deploying, and operating. And during this session, we're really going to combine the first two pillars, designing and building, into one. But via intent-based networking, this is how we're going to create that reliable data center. And what do we mean by intent? When you create a data center, or any network for that matter, but in this case, a data center, you want that network to operate in a specific way and to provide and to feedback a specific business and operational outcome. And that outcome is the intent. So whether you want a free clause model, intent, super spine, that's intent. With or without a DCI connection, that's intent. How many servers, the uplinks, the speeds, the port density, the VXLAN, the EVPN, policing, routing, all of that is the intent. And all of this can be done on the Apstra solution itself. And by creating these data centers on Apstra, you're allowing a repeatable operation. Because we are creating templates and racks and resources, you can deploy these operations throughout any data centers which are connected to the Apstra solution itself, which is of course going to minimize any human errors, and of course improve significantly the deployment and cost saving times associated to that. And absolutely, Apstra is the only multi-vendor solution on the market today. So Apstra, yes, of course, a Juniper solution, but we don't just work with the Juniper QFXs. We work with Arista, with Cisco, with Dell, and all the other vendors you can see here. It is a multi-vendor solution. And just for your review, recently there was a Forrester report which was released, and at Juniper we actually engaged this analyst firm, and the Forrester did an economic study for us, and they recruited 4 Juniper customers who have purchased and deployed Apstra, and at Juniper we had Forrester talk to them. And these customers, they covered a range of geographies and verticals, which you can see. But everything was anonymous. Juniper had no part in the interviews, in the conduct, in the output that these end users were actually providing to Forrester. What Forrester came back with was this report. So as you can see, a typical organization has a return on investment of around 320%. That is absolutely significant. The payback period is less than 6 months, and that is a very strong figure, of course. And that payback of, when we talk about the cost of the solution, that includes any licensing involved in that and any associated training. Day zero operations, 60% time and cost savings associated to what they were doing before Apstra to what Apstra actually saved them in terms of time and cost savings. The day one implementation, deployment, configuration. On average, the customer said Apstra brought this time down from 24 hours per switch to 2 hours per switch. And day two, where a lot of users spent a significant amount of their time monitoring the network and ongoing operations and maintenance and finding and resolving any issues there may be. Our customers said that Apstra saved them 60% of these costs as well. And day two, as I said, is typically the longest or the most part where users are going to spend a significant amount of their time. So absolutely, Apstra is not only unique, but it provides a significant return on your investment itself. And there are also additional benefits which are not quantified within that report. Multi-vendor, yes, I've said that. Freeing up resources, so you no longer need JNCIEs or industry experts to configure your data center. You're freeing up that expertise to work on other tasks, on other operations, wherever it may be. And you're increasing the scalability of your data center network. Of course, the time to market actually allows our customers and end users to cut this in half. And this is what they said, and you'll see this in the report if you search for it. It allows to cut in half the time required to stand up a new data center or scale an existing one. And actually comes out of the box already equipped with templates and building blocks that can be easily adapted for any environment. But also, just to show some business results here, just some quotes here. I'm not going to go through all of these, but as you can see, quite a few different quotes here, from ease of use, time savings, efficiency in operations, performance and functionality. Bloomberg saying, and the multi-vendor quote is very powerful here. They allowed them to have a single view of the entire network, regardless of the type of network, edge, rooted, or central rooted, 3 clause or 5 clause, doesn't matter, or even vendors and operator systems, it doesn't matter. It allowed them to have that single view of their entire network itself. And that in itself really does speak to the scale, the power of the Apstra solution itself. But no more slides. Let's actually go into the operations itself, into the day zero operations. So what I've got is an EVE-NG environment here, and this is what we're actually going to be building and designing on Apstra itself in just a minute. But just to talk you through, this is a free class. I've got 6 leaves here. Each one has a single server connected to it, and of course each leaf is connected to a different spine. Don't worry about the management IPs over on the left hand side. This is just for my connectivity in my EVE-NG environment. But what I really want to draw your attention to on this display is these pools here. Now these are the resource pools. So on Apstra you can actually create different resources for ASNs, the underlay, which is the fabric, loopbacks, whether it be the underlay or overlay, layer 3 VNIs, layer 2 VNIs. These are the resources that we're actually going to create on Apstra to eventually in the next session deploy and monitor this data center via day 1, day 2 operations. But what I'm going to do is I'm just going to minimize this display, because what I've got in the background is just a little notepad which I wrote up, which has these resource pools, which you'll find useful, I'm sure. So I've just accessed my Apstra solution. And on the left-hand side, you can see all these different tabs here. Now, what I'd like to point out first is that I've already done this for time savings, but I've created these managed devices which have connectivity, full control over these leaves and spines. So you can create on-box agents, off-box agents, which are communicating to and from the Apstra solution to those switches via the management interface itself, and you can have full control or telemetry only. This does take a few minutes to configure and to get full control over. So as I mentioned, for time savings, I've done this already for you. But what I'm going to show is how to create this resources, which we are going to use on the next session. So under the resources here, you can see we could create the ASN pools, the IP pools, IPv6, and the virtual network identifiers. So first, let's create some ASN pools. You can see there's some out of the box already created pools for you, but if you want to create your own ASN pool, which is what we want to do, all I have to do is create my ASN pool and give it a range. Now, when I deploy this in the next session, Apstra will automatically do this for me. I don't have to, I could create another one here, but I don't have to go onto the COI of each leaf of each spine and do that myself and configure the ASN for that particular device or for that particular data center if you're talking about BGP. Apstra does that for me automatically. I now want to create the IPv4 range for the fabric, the underlay. So I'm going to go to IP pools, and you can see I want to create a few here. So I'm going to call this the fabric. So this is the underlay, and this has a 172.16.1.0/24 range. I'm going to create another one, and this is the loopback. Now you can create different pools for loopbacks at the overlay or the underlay layer, or in this case, I'm doing it for both layers combined just to keep things simple. And lastly, I'm going to create my layer 3. Oh, I'm actually in the wrong tab. So let's come out of this and go into VNI pools. I want to create my layer 3 VNIs. Layer 3 VNIs. And the range will go from 5040 to 5100. Great. Done. So you can see nothing's in use here because I haven't deployed this here, but I'm initially doing the designing and building. My intent is to have, let's maximize this. My intent is to have these resources, these ranges of addresses and identifiers here deployed automatically and seamlessly over this network here, which I'm going to start building now. How do you actually build that network? So it's really a case in design going step by step. Now, Apstra is taken from the word abstraction. So you can actually see here that the spines, they've got 6 interfaces connected to 6 of the leaves, each in connection to each leaf. And the leaves themselves, they have 3 interfaces to each spine and 1 interface to each server, or as we call it on Apstra, the generic system for servers. Now, you're not going to see hardly any vendors out there which only have a 6-port solution or even a 4-port solution for the data center. But this is still my intent. So how can we do that in Apstra? Well, first I need to create my logical device. And you can see that Apstra comes with quite a few different out of the box created logical devices for you. But here I'm just going to call this my data center spine. So I'm going to create my data center, and I can define how many ports I want, up to, for one panel, 68 or more ports. But as I just showed, I only have 6 ports which are connected to my leaves, and they are all 10 gig itself. I'm going to create that port group. I can add another panel which can have 10 more interfaces, 20 more interfaces at 1 gig, 10 gig, 40 gig, 100 gig, doesn't matter. But here is my logical device for my spine. I'm now going to create a logical device for the leaf itself. So data center leaf, and this has 3 interfaces to the spines running at 10 gig. And I need to add another panel because there is 1 interface which is going to the, as I said, the servers which we call generic system. And that's it. I actually done that wrong. So 1 times 10 gig interface to the generic system. And if I create this now, and just to show you, if I now query on data center, I can see here's my logical devices which I just created for my DC spine, 6 times 10 gig interfaces, and DC leaf 3 times 10 gig interface and 1 times 10 gig interface to that server on each leaf. Okay, great. But this is an abstraction. This is a logical device. It's not actually mapped to any specific vendor hardware. Now, to map that to a specific vendor hardware, and just for your information, these are not Juniper switches. These are Arista virtual EOS switches. Yes, you heard me right. This is a Juniper solution, which is going to be managing, building, deploying, monitoring Arista-based data center devices. And that's just to show the multi-vendor support that we do have on Apstra. But how am I going to link these data centers, leaves and spines, these logical devices to Arista, to that hardware? Well, that's where the interface maps actually comes into it. So here I actually create a interface map. You can see there's quite a few, again, out of the box, already created interface maps for you, which link to Arista, and there'll be more. You can see there's quite a few pages for Cisco and obviously Juniper and more. But I want to create my own map. So let's call this interface map for the spine devices. I select my logical device. Now I need to select the logical device I just created, my data center spine. And I'm going to link this to an Arista VOS. You can see there's a lot of device profiles here, but here's Arista VOSs, and that is valid. And I'm going to say which interfaces do I want out of the 10 connected to the leaves. Well, I want 1, 2, 3, 4, 5, 6. Done. 6 out of 6 interfaces are created. I want to create the same interface map, but this time for the leaf. So interface map leaf. I select my logical device, my data center leaf, which I just created a few moments ago. And again, I'm going to link this to the device profile, which has all the hardware information and configuration, the COI input specifically for Arista, and much more. That's what device profile is, but I'm going to link this to Arista VOSs. Now I say which interfaces do I want the leaves to connect to the spine. So if I come back to topology, you can see if for each leaf it is interfaces 1, 2, 3, 1, 2, 3, 1, 2, 3. So here I'm just going to say interface 1, 2, 3, and it's gone green. The fourth interface is connecting for each of the leaves are connecting to the generic systems, the servers themselves. So if I select the interface, I want interface 4. It's another free available, of course. And that's it. That is my interface map actually created. What next? Well, now we actually define the racks themselves. The racks are where you place the TOR, the top of rack leaves, and how many servers you want in each rack, and how many connections you want in each rack, so on and so forth. And again, you can see predefined racks for you, so you can be up and running a lot quicker if you didn't want to define your own. But here I'm going to create rack 1, and I'm just going to call this rack 1 leaf 1. Here I'm going to define my logical device, which I just created, my data center leaf. I'm not going to have any redundancy, and you can actually see on the right hand side here, this is the leaf. Now, so this would be the Arista VOS, which is linked via that interface map to that logical device. But of course, it's missing that generic system, i.e. that server itself. So here, by clicking generic system and add in the generic system, I can then say this is rack 1 server 1, just for example. You do need to define the logical device for this, for the server itself. So this is an AOS 1 by 10 gig, and the link. So we can have a number of links connecting the server to the leaf. It's only one connection, as you can see here. So I'm just going to call this link server to leaf. And it is running at 10 gigabits per second. That is it. I can then create another leaves. This should be rack 2. Rack 2, leaf 2, logical device, PC leaf, 10 gig, no redundancy, great, done. Generic system, going to add the server, rack 2, server 2, logical device, 1 by 10 gig, add the link, server 2 leaf. And that is the second rack created. And you just basically need to keep, because I've got 6 racks here, 1, 2, 3, 4, 5, 6, I need to obviously do this 6 times. So let's go create another. Oh, I forgot to give it a name. So this is rack 2. Great. Rack 3. Rack 3 leaf. 3. Logical device. Data center leaf. No redundancy. Add my generic system. Server. Rack 3. Server 3. And hopefully you can start to see how much time this is actually saving versus the old traditional CLI approach and other ways, of course. But link server to leaf. Done. So at the bottom, you can see I've already created my 3 racks. I'm going to create the other 3 just quickly, just so it's a full design and full build. So rack 4, rack 4, leaf 4, a logical device, 1 by 10 gig, generic system. Note you can create and configure access switches, which will not be monitored, managed by the Apstra solution, but you can nonetheless create that architecture on Apstra and then configure your switching and routing policies to the access switch, which might provide connectivity to an external router for DCI connection, just for example. But rack 4, leaf 4, server 4. This is 1 by 10. I need the link, of course. Without the physical link, of course, nothing's going to work. Link server to leaf. Done. Five, nearly there. Rack 5. 5. My logical device is that of the spine. Sorry, of the leaf itself. Generic system, rack 5, server 5. 1 by 10 gig. Need the link. Link server to leaf. Note again, you can enable link aggregation group here. Again, just to reiterate, there's no redundancy here, just to keep the setup simple. And last one, rack 6. Rack 6, leaf 6. Select my logical device, data center leaf. Note you can add more leaves here, so you can have up to 2 leaves per rack. I'm just going to delete this, or maybe even more, actually, more leaves, but I didn't fill it out. And go back to my generic system, rack 6, server 6, logical device, 1 by 10 gig, physical layer, need the link server to leaf. And just to show you, if I increase the number of counts, physical link per leaf, okay. That's why I've only got 1 server, that's fine. That's fine, but if I actually create this now, you can now see at the bottom I've got 1, 2, 3, 4, 5, 6 racks with a single leaf, which is connected to 1 generic system. 1, 2, 3, 4, 5, 6 leaves, each connected to 1 generic system. Okay, great. But how are we going to aggregate as such all of this together? These are the racks, these are the leaves, these are the generic systems. But as you can see, I've got my spines. Where do the spines get configured and built? Well, that is the next step. So we've configured and created our racks. We've built our racks. Now we aggregate this all together in a template. And the template is where we start to define the spine layer. Again, note, you have predefined templates for you, but we're going to create our own. This is my data center template. It's rack based or 5 clause or maybe a collapsed leaf spine architecture. I'm using a unique ASN allocation per spine. I'm going to use MPE-BGP, or you could configure static VXLAN for the control protocol, but pretty much everywhere is using multi-protocol eBPG to advertise eVPNs, and I'm going to use IPv4. So, and note you can create and import your own routing policies as well, but I'm going to use the default. So now, where do I configure the template, the spines, and really the connectivity of the spine to leaf layer? Well, first I need to add the racks. I just created 6 racks. So scroll down, rack 1, you can see it's been added. Spine 1 has automatically been added in there. Rack 2, rack 3, rack 4, rack 5, and rack 6. There are my 6 racks with my top of the rack leaf switches, 1 generic system, 1 server on each. But I need 3 spines. I've only got the 1. First, let's just say, well, the logical device of this spine, yes, we know that the physical hardware is that of an Arista, but the logical device is a DC spine with 6 by 10 gig interfaces. And I need 3 because that is my intent. Now I can say, linked super spine, this is if you define it to be pod based, but so we're not going to be able to configure this. But if I actually show the links here, you can actually now see that each leaf, because I designed the intent for each leaf to have 1 connectivity to each spine, when I was building the logical devices, I defined that there would be 3 interfaces to each spine and 1 interface to each generic server. So by creating that logical device, and then by saying, well, there's 3 spines, Apstra knows actually you need 1 connection to spine 1, 1 connection to spine 2, 1 connection to spine 3 for each one of these leaf devices themselves. So that is a full connection here, and it looks exactly the same minus the type of lines and the color of lines and the user interface. That is the design here. That was my intent. The resource pools, the leaves, the spines, how it's connected, and I have just configured all of that within a matter of minutes on Apstra. And now if I click on the DC template, which I just configured, you can see all the information here. So that is how I built it and designed it in a matter of minutes. So coming back to the slides, hopefully there you can see how quick and easy it is to use Apstra to design and build your data center. You can build and design your data center before the hardware is even installed in your network. And because I've created those logical devices and those interface maps and racks and the template, I could use that for other data center deployments, for other environments, for other data centers. And that again is allowing that repeatable operations to take place, and it's giving you assurance that there's no errors and you're reducing the complexity. And as I showed, those leaves and spines weren't Juniper, those were Arista. This is the only true multi-vendor solution out there. And just to show you, we are Juniper's AOS Apstra operating system. It is a leader in the Magic Quadrant for the data center and cloud networking. We also have a Gartner Award for being a cool vendor in enterprise networking. And just so you know, Gartner even had to invent or create, I should say, the intent-based networking system category because of Apstra, because it's unique, because it's so powerful and agile. And as you can see, the intent-based networking system can reduce the number and duration of outages by at least 50%. So I thank you for your time. And once again, thank you to our partner Kubus for hosting these sessions. And if you do have any questions, please contact them at email sales@kubus.com, and they'll be more than happy to take any questions you may have. Thank you for watching, and I look forward to taking the third session, where we will be deploying that data center, deploying the tenants, tenant 1, tenant 2, tenant 3, and all the extra information therein, within that third 30-minute session. I look forward to taking you through that session. Thanks for your time and goodbye.